The water cycle is a delicate dance, a mesmerizing and vital process that sustains life on our planet. Water in its various forms is constantly moving and changing, flowing through rivers, crashing onto shores and cascading down waterfalls. This continuous process, known as the water cycle, is a complex system that involves multiple stages and transitions, a process involving evaporation, condensation, and precipitation, each step intricately linked to the next. The sun's energy heats the Earth's surface, causing water to evaporate, turning into an invisible vapor. This vapor rises into the atmosphere. There it cools and condenses into tiny water droplets, forming clouds. These clouds drift across the sky, carried by the wind, and eventually release their moisture as precipitation. This precipitation replenishes our water sources, ready to begin the cycle anew. Water vapor, the gaseous form of water, often evokes images of calming mists and gentle clouds. It's a natural part of our atmosphere and is essential for life on Earth. We often associate it with pleasant weather phenomena like a refreshing rain shower or the soft embrace of fog. In some ways, water vapor can even have a cooling effect. For example, when we sweat on a hot day, the evaporation of that sweat helps to cool our bodies. Similarly, cloud cover can reflect sunlight back into space, reducing the amount of heat that reaches the Earth's surface. This reflectivity can have a localized cooling effect, especially during the day. However, beneath this seemingly benign exterior, water vapor harbors a powerful secret. It's a potent greenhouse gas, even more so than carbon dioxide. While it might appear harmless, water vapor plays a complex and often overlooked role in the story of climate change. As a greenhouse gas, water vapor traps heat in the atmosphere, contributing significantly to the greenhouse effect. This trapping of heat is amplified by the fact that warmer air can hold more water vapor, creating a feedback loop. Human activities, such as industrial processes and urbanization, can increase water vapor levels, exacerbating this effect. The increased heat retention leads to more severe weather patterns, melting glaciers and rising sea levels. This wolf in sheep's clothing can thus drive extreme weather events, from intense storms to prolonged droughts. Understanding the dual nature of water vapor is crucial for scientists as they model and predict climate change impacts. By recognizing its role, we can better grasp the complexities of our climate system and work towards more effective solutions. The Earth's atmosphere acts like a giant blanket, trapping some of the sun's heat and keeping our planet warm enough to sustain life. This is crucial for maintaining the delicate balance within the ecosystems. Without this natural insulation, our planet would be a very different place, unable to support the diverse forms of life we see today. The warmth provided by the atmosphere is what makes Earth habitable. This natural process is known as the greenhouse effect. It is a fundamental aspect of our planet's climate system, playing a key role in regulating temperature and weather patterns. Without the greenhouse effect, Earth's average temperature would be a frigid -18 degrees Celsius, far too cold to support most forms of life. This would result in a planet covered in ice, where the varied variety of mammals would not even could exist. The greenhouse effect works because certain gases in the atmosphere, known as greenhouse gases, trap heat from the sun. These gases include carbon dioxide, methane, nitrous oxide, and water vapor. These gases allow sunlight to pass through the atmosphere relatively easily. When sunlight reaches the Earth's surface, it is absorbed and then re-radiated as heat. However, when this sunlight is absorbed by the Earth's surface and re-radiated as heat, greenhouse gases absorb and re-emit some of this heat back towards the Earth. This process helps to keep our planet warm. This trapping of heat warms the Earth's surface and lower atmosphere, making our planet livable. Without this natural warming, the Earth would be a much colder and less hospitable place. Water vapor is a major player in this process. It is the most abundant greenhouse gas and plays a significant role in regulating the Earth's temperature. In fact, it's responsible for the largest portion of the natural greenhouse effect, accounting for about 2/3 of the warming effect. This makes water vapor a crucial component in maintaining the Earth's climate balance. While water vapor is a potent greenhouse gas, it's important to understand that it behaves differently than other greenhouse gases like carbon dioxide. Water vapor is unique because it is both a result and a driver of climate processes. Its presence in the atmosphere is largely controlled by temperature. Unlike carbon dioxide, which remains in the atmosphere for centuries, water vapor has a relatively short residence time. This means that its concentration can change rapidly in response to temperature fluctuations. On average, a water vapor molecule stays in the atmosphere for only about 10 days before returning to Earth as precipitation. This quick turnover is a key factor in how water vapor interacts with the climate system. This short residence time means that water vapor doesn't directly drive climate change in the same way that carbon dioxide does. However, its role as a feedback mechanism is crucial. Instead, it acts as a powerful amplifier of warming caused by other factors. When the atmosphere warms, it can hold more water vapor, which in turn enhances the greenhouse effect. This is because warmer air can hold more moisture. The relationship between temperature and water vapor is exponential, meaning that even a small increase in temperature can lead to a significant increase in water vapor. As the Earth's atmosphere warms due to increased concentrations of carbon dioxide and other greenhouse gases, the air can hold more water vapor. This additional water vapor then traps more heat, creating a cycle of warming. This additional water vapor further enhances the greenhouse effect, leading to even more warming. This process is a key component of what scientists call a positive feedback loop. This self-reinforcing cycle is known as a positive feedback loop. In essence, the warming caused by greenhouse gases like carbon dioxide leads to more water vapor, which then causes even more warming. Understanding this feedback mechanism is crucial for predicting future climate change and its impacts on our planet. Human activities, such as burning fossil fuels and deforestation, release massive amounts of carbon dioxide and other greenhouse gases into the atmosphere. We also directly release water vapor through activities like irrigation and industrial processes. However, these direct emissions are relatively small compared to the vast amounts of water vapor naturally present in the atmosphere. While human activities may not directly contribute significant amounts of water vapor to the atmosphere, they are indirectly influencing its concentration through the warming effect. As the planet warms due to human-caused emissions, the atmosphere's capacity to hold water vapor increases. This leads to a positive feedback loop, amplifying the warming effect. Therefore, even though our direct contributions of water vapor may seem insignificant, our impact on the climate system indirectly affects water vapor concentrations and contributes to global warming.